All right, 1-9 is finding inverse functions. And what we're going to do is we're going to be finding the inverse functions and verifying that two functions are inverses. We're going to be using the horizontal line test instead of vertical test to see if a function is one-to-one and therefore has an inverse. And then use inverse functions to model. So a function assignment, output value y, a function assigns, I had to fix that, output value y to each of its input values x. An inverse function maps the output value back to the original function. This means the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. And if you remember from Algebra 2, I think you did inverse functions. To find an inverse, all you did was you flip the x and the y. So for example, if f of x contains the points 1, 1, 2, 4, 3, 9, 4, 16, then its inverse, which is written f raised to a negative 1. Guys, that does not mean 1 over f of x, okay? You see f negative 1 of x, that means the inverse of f of x, is simply the ordered pairs just switched. 1, 1, I switch them 1, 1. 2, 4, become 4, 2. 3, 9, becomes 9, 3. 4, 16, becomes 16, 4. That's what an inverse function is. All right. Two functions are inverse functions if and only if we find that f of g of x is x and g of f of x is x. So that means when I do the composition of the functions both ways, we get x. It has to equal x. It'll not equal, if it equals anything else but x, they're not inverse functions. So verify that 9 minus x squared, where x is greater than 0, and g of x are inverse functions, both algebraically and graphically. So A, how do I do it algebraically? Well, we find f of g of x that means I take f and I plug in the square root of 9 minus x in for it. My f function is 9 minus x squared, so that's going to be 9 minus the square root of 9 minus x, quantity squared. Square root squared, what happens to it? Cancels. And we get 9 minus 9 plus x, which does in fact equal x.
How'd you get plus x?
Because I'm subtracting the whole quantity 9 minus x. So I've got to distribute the negative to everything in here. Just because I got x here doesn't mean I don't have to do this. Okay? You have to do both ways. When I ask you to do it algebraically, you have to do both. So that means I'm going to, where I see the g function, I'm going to put in 9 minus x squared. Well, the g function is 9 minus x, so that's 9 minus the quantity 9 minus x squared. Distribute the negative 9 through. Distribute that through, we get plus x squared. And we get x. Do what? I believe this should be less than or equal to 9. That's a typographical error here. B, algebraically, and we've got these graphing calculators here. Let's just plug them in. Y equals, first one is what? 9 minus x squared. Second one is the square root of 9 minus x. And let's do Zoom standard. Let's do Zoom 6. Can I? Let's make this 0. Make it from 0 to, what did I plug into what? I did the 9 minus x squared and the square root of 9 minus x. These functions right here. 9 minus x squared and the square root of 9 minus x. These are the functions I want to algebraically see. If we flip it over before we look at these graphs, it says that the graph of f of negative 1 is the reflection of the f of x graph on the line y equals x. If the point AB is on the graph of f, then the point BA is on the graph. So let's look at our graphs. Let me see. If I do this, will that help us any? Not at all. There we go.
Wait, why does it look like that?
Okay, this point over here is the point what?
How'd you get it how'd you get it to look like that?
Windows 0 to 10. What is this point right here? That's 9, 0. What's this point here? 0, 9. Let's go and let's put this third function. Let's do y equals x in there. And let's hit graph. Do you see the reflection? That this part of the red is reflected right here. This part of the red is reflected there. If I would fold along this line right here, this part would fold up to here. let's see. Let's go back to the windows. It's hard to see. Ignore this right here for a minute. It was hard to see. Can you see better this here on your graph? If I fold along here, how it's going to match up there even better. We need square. You now could see better that this right here, when I fold it, this will fold right up there. From here, here will fold down here. Okay, hard to see because of the zeros and stuff. We're ignoring anything to the left here. All right. Example 2. Use the graph of the function f to create a table of values for the given points, then create a second. So the table, well, I don't have the graph here. Do you guys have a graph?
No.
Well, let's make one. Who cares what it is? Let's go here, here. Let's go here and here. So when I make that table, we have what? 1, 2, 3, 4, -5, 6. And then we have -2, 0, 3, 2, 7, -3. So what's the inverse, the table for the inverse function? All the values switched. So it's going to be what? 6, -5, 0, -2, 2, 3, -7. How about -3, 7? So 6, -5. 0, -2. 2 and -3. Questions there? Alright, a function f has an inverse if and only if no horizontal line intersects the graph f at more than one point. Each output value is assigned to only one input value. The output values cannot be repeated. Recall in a function, the input values cannot be repeated. So what do we got? Use a TI-84 calculator. So we're going to graph these on your calculator. Make sure you clear out all your y's. And graph 4 minus x divided by 6. Make sure you put that 4 minus x in parentheses. And hit window, hit zoom 6 so we all have the same graph. When you draw a horizontal line, how many times does it cross it? One time, so this is 1 to 1. Questions there? What's this next one look like? We don't even need to put this in our calculator. It's a horizontal line going this way. How many times will another horizontal line cross it? Many times. So this is not 1 to 1. What about if it was x equals? It would, yes. Okay, next one. How do you get the absolute value signs on here? Any ideas? Math. Math is right underneath alpha. Go over to numbers. And right there it says ABS. Hit enter. There's your absolute value. Let's try that again. Math, numbers, number 1. And that's x minus 2. Take your right arrow to get out of the absolute value. Parenthesis, divide. Parenthesis x minus 2. Absolute values work as a parenthesis. Hit graph. What do you get here? Is this 1 to 1? No, I draw a horizontal line, it's going to cross again, so not 1 to 1. Last one. Y equals parenthesis x minus 1 up arrow 3. Okay, graph. Is this going to be 1 to 1? It looks flat right here, but if we zoom in, you can see it's really not flat. It's just getting very close. So yes, this is 1 to 1. Example 4. Up above here, use a horizontal line test to determine if it has an inverse. Replace f of x with y. Then change the x and the y's around. So verify. So example 1, find this inverse. I'm going to tell you yes, it has an inverse. So first of all, y equals the fourth root of x minus 3. So number 1, you graphed it first. Number 2, what's the domain here? Okay, here's what this graph looks like. So what's its domain? What? X is greater than or equal to 3. Because you know, underneath here it can't be negative. Looking at the graph, the range is y is greater than, y is greater than or equal to 0. So number 3, switch the x's and the y's around. And we need to solve for y. How do I solve for y? So what do I do to get y by itself?
3 over there.
Not yet.
So it's the fourth.
Raise it to the 4th power. So this is going to be x to the 4th equals y minus 3. Then what? Add 3. And then what? I add 3 over. What's the domain of the new function? Well, the range was y is greater than 0, so the domain is x is greater than 0. For the range, the domain was x is greater than 0 or greater than 3, so y is greater than 3. Remember, your domains will flip too, but it'll still be x and y. That's the 4th. And then 5th, verify. That means you're going to take f. The 4th step was right here. It was replacing the f. Make it right that way. So f of x to the 4th plus 3 and then f inverse of the fourth root of x minus 3. So the fourth root of x to the fourth plus 3 minus 3. My original function was x minus 3. So when I replace the x with x to the fourth plus 3, I still have that minus 3 out there. Okay? So the fourth root of x to the fourth is x. You finish this to verify it.